This example problem is exercise number 76 on page 33 of the textbook. The problem reads, a roofer drops a nail that hits the ground traveling at 23 meters per second. How fast is the nail traveling 2 seconds before it hit the ground? Okay, so we carefully read the problem. First, we determine what we're being asked to find. Okay, so it says a roofer drops a nail that hits the ground traveling at 23 meters per second. How fast was the nail traveling 2 seconds before it hit the ground? How fast? Sounds like it's looking for a velocity. Right? It's looking for a velocity. So maybe I could say velocity at 2 seconds before hitting the ground, to be specific. Give it. Let's give it. It says, drops a nail that hits the ground traveling at 23 meters per second. Now it's hitting the ground traveling at 23 meters per second. So I'm going to say that's its final velocity, right? Because there can't be a velocity after that, it's hitting the ground. So its final velocity is 23 meters per second. Let's draw a little arrow just so I know it's down. It's traveling downward. How fast is the nail traveling 2 seconds before it hits the ground? So the time is 2 seconds. That's when we're looking for this velocity. So I'm going to say this is its initial velocity, right? We're looking for its initial velocity. Its initial velocity, and then it says 2 seconds later, its final velocity is 23 meters per second. What other information do we know, or is it assumed? Okay, well, it's saying it has a different velocity, right? What is its velocity 2 seconds prior to hitting the ground? That's inferring that its velocity must be different. It must not be 23 meters per second. So the object is accelerating. What is its acceleration? Well, this object, it's a nail, right? And it's falling, so it's in free fall. So its acceleration is g. All right? Now, g is 9.8 meters per second squared. So now I have, is there any other information that's given? I don't think so. I have to define my coordinate system. I gotta say which direction is positive, which direction is negative. Since I know the object's traveling downward, acceleration due to gravity's downward, everything's going downward, just seems easier just to make downward positive. So that's what we're going to do. Some are very visible and say downward is the positive y direction. So that means this is a positive because it's downward, and acceleration due to gravity is downward, so this is a positive. If I would have made up to be positive, this would have had to be negative, and this would have had to be negative. All right, and the equation. Well, I think it's the definition of acceleration, change in velocity over change in time. Right? So we have acceleration equals v final minus v initial divided by time. That's our equation. We got to solve this for what we're looking for. What are we looking for in this equation? Not acceleration, not final velocity, not time, but initial velocity. So to solve this, we multiply both sides by t. And to solve for vi, the initial, we can add this term over here and subtract that term over there. Okay. Now we have the equation solved for what we're looking for. And now, once it's solved for what we're looking for, Now we plug in the numbers, okay? So I strongly encourage you solving the equation for the unknown value that you're looking for, and then plug in the numbers. So V final is 23 meters per second minus our acceleration is 9.8 meters per second squared times time is 2 seconds, and we get V initial is equal to, we get 23 minus 9.8 times 2 is 19.6, 3.4. Okay, circled it. Now assess. It's less than that. That makes sense, right? Because it should be speeding up. It doesn't take long for something to fall, so 2 seconds might be the majority of its trip. Because 2 seconds is a decent time to fall. It doesn't take, takes maybe not even a second for this pen to hit the ground. So it makes it, maybe it's not that, it's not traveling extremely fast. So it seems like a reasonable answer, 3.4 meters per second, which I feel pretty confident in. So 2 seconds later, it will speed up by 19.6 meters per second and be traveling at 23 meters per second. So here we have our final answer.